The second application is the modeling applications, which is simply simulations. A simulation means a computer model that uses mathematical formulae to describe a real life situation. This simulation will attempt to mirror or reflect the rules and mechanisms that control real life systems. And then it will apply these rules into a computer program so the models can simulate the real life reaction under different circumstances, different conditions. We'll study personal finance, bridge and building design, floodwater management, traffic management, and weather forecasting. Before we start, the modeling applications are really helpful. Take a minute, think about if you want, for example, to build a ship. So, is it better that you build this ship, construct it, and just put it on the ocean or put it on the sea and start sailing? Or you'd make a design with a computer and see how will the ship overcome wind, high waves, low waves? Obvious answer is it's better that you make a design first, model it, and put it under different conditions and try to see how is it going to act. So this is simply the meaning of modeling applications. With the personal finance, it means creating a plan that can manage a personal budget, comparing the income with the expenditure. How can we get more profit if we have a small business? What are the best ways to reduce our expenditures? How can we have more savings? And the best application to do this is known with a spreadsheet, Microsoft Excel, which has the analysis of what if. It allows us to ask many questions and have their answers. The second one is bridge and building design, and is the same question that we have asked earlier about the ship. So same thing with the bridge and building. It's better that if you can design a building or a bridge and then test it over heavy traffic, adverse weather conditions, for example, hurricane, earthquakes. If there is an accident, a traffic jam or congestion, how many trucks that this bridge can hold? What would be the tension over the bridge? There are too many things that we can simulate, and then we can get a good result out of it so we can know how can we build this bridge. Same thing with the building simulations, they give us the opportunity to check how the building will act if we have earthquakes. We can zoom in and find exits for emergency exits, and then we can, let's say, change the location of exits to have fastest, safest exits for people to leave this building in case of, for example, a fire incident. The third application is the weather forecasting, which means predicting the weather conditions for the next few days or weeks. Basically, the weather forecasting, the one that you might see on the news, if you watch news, it depends on previous situations, previous readings on the same days, like on the last year, the year before, and try to expect what is going to be the weather on the next few days. The readings will be taken for the weather forecasting. For example, what is the air pressure, the wind strength, how like the moisture, the humidity in the air, okay, the temperatures, if we have rainfall. So the weather forecast will help us to know what's going to be the weather for the hours or days. The fourth application is traffic management. With the traffic management, it means traffic modeling. We'll develop information that can support the decision where to go and manage the traffic system. So it will direct the vehicles, pedestrians, which means walking people, to the best routes, which will allow us to have the optimal traffic flow, which means we will have the minimum traffic jams. The traffic modeling means the simulations of real world traffic to ensure the optimal flow. Now, the top of the decisions that the traffic modeling that can help are determined by which type of control to use at road junctions. Like if we have a place where we have crossroads when there is a junction in the middle, so which direction goes first? The traffic lights, in which way that we can give the opportunity for which side roads to enter the traffic, which one goes after that. So how can we deal with the busy hours? Which road or which side that comes with the um, largest amount of vehicles, so we can ensure that we can investigate the effect of also building new roads or allowing only one-way traffic. The last application is the floodwater management. There are so many places and areas on earth that they have earthquakes and they have flood, like tsunami. So the models will help us to predict where are the most vulnerable areas where we have the possibility of flood water. So it can predict the depth of the flood, can calculate the coastal risk, and also it will help us with risk management, which we use the hazard maps. The hazard map is a map that will indicate or highlight the vulnerable areas for a particular adverse condition, like flood water, a earthquake, hurricanes. So how can we get evacuation plan? So the flood water management system can help us to do this. What are the advantages and disadvantages of the modeling applications? The first one is safety. Like the buildings can be modeled or remodeled without any human risk. So you can build the whole building in the simulation, break some parts, remove some parts, add some parts without doing this in real life. So this is more safe. It's less expensive because you don't have to do physical prototypes. You can test the building, you can test the bridge, even for impossible or very hard, complicated situations. You will get fast results and quick results with more sophisticated mathematical equations. We can say also perfection before construction. Main disadvantages, sometimes the situation is too complex to be simulated, which will lead to fail in the model. The rules that can identify how the simulation work, sometimes they become too difficult and it will need more work, more mathematical work, more speculations, more investigations. Also, the reality versus model. The models may fail in the real life, and vice versa. The real life cannot be simulated. The model is not reality. The results or answers may turn unexpected. Sometimes the model setup is too expensive to build a physical model. So this is also another problem. The human beings can make mistakes as programmers or as mathematical scientists. An accurate model with a human error, as we said, programmers and mathematical calculation. So all of these could lead to a fail in the model. People, they might not react positively with the results of the simulation. Like some people, they don't trust the outcome of computer models. And as we said, building the real thing can be expensive. Sometimes making a computer model is going to be more expensive than building a physical one. These systems, again, are as good as the programmers and mathematicians they worked on, also as good as the data entered. Still, yet, these systems are not real. We still have to test real life systems.